Okay, I'm realizing that the document that I scanned online is a little bit different than what it is that I have in front of me. So I have a version in front of me that I know I made some changes to at the end of last year and thought that what I had online was the changed version. I realize that it's not. Just the last example on my page, I think I had whatever 6 and 19. I think for your page, it was 6 and 9. So there's a couple of some small tweaks and changes. The biggest one though is on page 5. So I see page 5. I had information that was just this is what I get. I got some stuff offline, trusted it, and realized it was not right when I started digging and doing my own research. So this over here is on page 5. Now, this is what it should be. So I want you to copy this down and probably, and overwrite this little box for intersection and union on page 5. Because right down here is information that you definitely want to have that I realize is really it's off on the document that all of you have access to. So it needs to look like this. So make sure that that or symbol, so let's say here you're taking pieces of data that you need all of it. You have to use your data that is on different sides of zero, or let's say they all do not come together. And I think I have the wrong symbol on page 5 for your document. I have this upside down U here, which is a symbol we're not even going to use. So in this particular case, for this example, it's or. So now you want either this information, you want this data, or this particular data over here. You can't have all of these pieces together at one time. So now, whenever we have or, we're going to use this regular U symbol, meaning that we are going to combine these two pieces of data. Now, we cannot go all the way from, in this case, negative infinity to infinity. I mean, using all of these real number pieces of information. I just want from negative infinity to 2, including 2. I also would like to use from 3 to infinity, not including 3. And that's what this example is saying here. So now there's a couple different types of examples that we're going to see. We're going to work out 2 right here. And then we'll hopefully, I haven't worked these out, so I don't know what the answers are going to be to them. But I hope that they would give us a wide variety of what these answers could look like and what they could be. But make sure this on page 5, if you already just printed out the other document, cross out this area for intersection and union and write this down. Or if you're able, I don't know, yeah, however you got to do it, but make sure you get this information down for intersection and union for page 5. All right, so now we're at the top. So page 4 here, we are looking at compound inequality to interval notation. So we're looking at these examples to complete. So here, page 3, we're done with that one. So now page 4, we're looking at taking a scenario here, and then from this scenario, are we going to combine them, or are they going to be separated, where we either want this or we want that? We can't have everything all together at one time. So let's look at this. So on page 4 at the top, you have a couple of examples one example that we talked about what it is, and then we said exactly what it means. So now there's only 2 on this page for page 4, but I'll work out the top one. You'll work out the bottom one a little bit later. Hold on, let me see if I can disconnect my keyboard. There we go. That makes it a lot easier to work with. So now competitors must be at least 14 but not exceed 18. Let's say you're at a karate competition and you have to be at least 14 but not 18 to be in a particular age group to kind of make sense of this here. So let's go here. Let's go with C. So let's say that C, your competitors must be at least 14. So the youngest that they could be is 14. So that means that you have to have, let me see here, I think it's going to be, let me see, do I want that one here? Let me see, must be at least 14, but not exceed 18. This says here, I want all numbers that are less than or equal to 14. That doesn't make any sense, so we don't want that one. So that means here, we want a scenario situated Right, where 14, you want all values or all participants that are equal to 14, which is what that underlined bar means there, or greater than 14. Okay, so now we've taken care of the first part, at least 14. We have that. But they cannot exceed 18. So that means your competitors also, the oldest they could be is 18. They can exceed 18. So that means that you have to have your participants that are less than or equal to 18. Okay, that's that one there. Or they have to be greater than equal to 14. Okay, we have that one. I probably should have did the work over here off to the side. So my apologies. I have so much stuff over here. I probably should have wrote it over here off to the side. So we were saying that okay, all your competitors had to be at least older than and equal to 14. But also you have to have competitors that are equal to 18 or younger. Okay. So this says we want this in inequality notation, right? So my two n points, or my two n in this situation, ages, are 14 and 18. Okay. So we know they have to be at least 14. So if you are 14, you can still be in this competition. So that means that we want to include 14. And they cannot exceed 18, but you can be 18. So this inequality notation means that here, okay. So then now what it means is from 14 to 18, we can do years of age, but we'll just go from 14 to 18. We want to include 14 and 18. This is where that include is important for this one scenario. So if you are 14, you can still be in this competition. Let's say it's something you've really trained and you fought for. If you're 13, you can't be in it. If you're 19, you can't be in it. So this is where that equal to comes into play. And that's the first example there on page 4. You only have 2 examples. So I just did the first one there for you there. But it's just kind of having to break down. You probably want to see if you can put it into inequality notation first to make a little more sense of it, and then put it into interval notation. Oh, I didn't do it right, so my bad. So yeah, so inequality notation is up here. I had it right the first time. And now interval notation is right down here. I didn't see this. I wrote the document and didn't pay attention to it. Okay, there we go. Now I'll take this and take that off because we had this right the first time and I wasn't paying no attention. So I apologize if you're looking at this with me and you went on ahead and erased what you already had. It's my fault. So we're saying here as inequality, yeah, we had that one. So we are going to go, how do I want this one here? So we're saying here that all of my competitors, they have to be greater than and equal to 14, but they also have to be less than and equal to 18. So this is how your inequality notation ties into your interval notation. That's what we're going to do there. So you just kind of but we realize though, right, you can fall in between. So this is where it's a compound inequality because now you have a situation where you can fall in between both categories. If I'm 15, I'm greater than 14, but I'm definitely not older than 18. So this is where your compound inequality comes in. We talked about page 5, your intersection and union. Make sure that you copy these notes down because these are the exact ones that you want to have. I think what you already have is probably incorrect if it's the document that I think that was still uploaded. Last one here, page 6. T is greater than and includes. So now we don't really have any scenarios here. Now it's just straight inequality interval. Do you understand what it says? So t is greater than and includes -2. So let's put that as an inequality. So t, I just want to switch colors up just to do it. So t is greater than and includes -2. Is greater than and includes -2. And t is, you know what, let me do it over here. Let me just get it over here first and see if I got it right before I start saying that's the answer. So here we go. So t is greater than and includes -2, and, but the fact that it says and t is less than and does not include 4. Okay, so now we have a set of data that's in between. It says that t has to be greater than and include -2. So I know I have my -2 is the smallest number I'm going to have on my data set. And I see that t is going to be greater than and equal, or it includes -2, and t and your value that you're looking for are also less than 4. So in this case, we can look at 0. 0 is greater than -2, but 0 is also less than 4. So now we have the interval notation. Now we'll start with just writing your two end data points first, always, right? The two endpoints. Now it says that your -2 is going to be included, so you have to have that square bracket. But your 4 is not going to be included, so that's where your parentheses comes in. And then, oh, but this is an OR problem. Great. So that was AND. So this is how your ANDs are going to look. Your ANDs are going to be set up just where you have one piece of information inside of your either brackets or parentheses saying that from this data point to this data point, what we have in between we want. This next one doesn't work the same. So that's the thing. I'm glad this is a good one that we have to work out here. This is the last one that we're going to do. It's already 11-minute video, so we're going over what I wanted to. Excuse me. Time is less than and does not include -7. So time is less than and does not include -7. Or time is greater than and includes -1. So now we're looking at two separate pieces of data where there's no number that could satisfy both, right? For the one that's in blue right here on page 6, I said 0. 0 satisfies both of those inequalities. It is greater than -2, but it's also less than 4. So now we're looking for data here. It says that you're looking for time that's going to be less than -7 or greater than -1. Let me look at a number. 5. 5 is greater than -1, but 5 is nowhere near less than -7. So this is where we have our OR here. So for inequality notation, we want to have, and I think we already have it set up for the most part. So we have our t is less than -7, or t is greater than equal to -1. So we already have the inequality set up. Those are two different scenarios. So basically, you just have to read it and take your time deciphering exactly what the question is saying. They aren't, you see, these are like just a couple of words. They aren't like 5 and 7 sentences, but you got to pay attention to what you're reading, though. And then for interval notation, I'm glad we have this example up here that we can pull from for interval notation. So for interval notation here, numbers that are less than -7, right? So that means that this is going to infinity. This is every number you can think of that's less than -7. So we're going negative infinity to -7, right? But -7's not included. So we're going to put a parentheses around this. But also negative infinity, you can't contain that. It's not a number that you can actually plot somewhere. You can actually try to calculate. It means that it's ongoing. So anything with infinity, you're always going to have a parentheses because you can't put a bracket around infinity. Then we have or. So this is our union saying that we want information that's going to follow either one of these situations that we have here. So I want that information, or I want to be able to have -1, but I want to include it, or I want to include -1 and all numbers that are greater than -1, which goes to infinity. And then at the top of page 5, there's a thing for four possible infinite ends. So you want to look at that. So I give you this. There's an interval and inequality as an example on page 5. I think it's right above these notes that I have over here on the right hand side. You want to look at in terms of how infinity is going to be utilized. And then on page 6, we just worked out 2 examples. You only have 3 other examples to do. And then this whole entire document is done. But you'll need this for some more important concepts moving forward. So, yes, this is pages 4. Excuse me, 4. Man, I can't even get it out. Pages 4, 5, and 6. Okay.